Okay, so this is for those of you who maybe were not in class and didn't really understand how these equations work. So what I do want to point out first is that very similarly to how math is operated, if there is a number like this 6 right here that is telling me that there are 6 molecules of CO2, there are 6 molecules of H2O, which is water, and then there is no number here, so this is an implied 1. We don't need to write 1, but what I want you to understand is that there's 1 molecule of glucose, C6H12O6, and that there are 6 molecules of O2 or oxygen. The same thing applies to any chemical equation that you have. If there is no large number in front of the molecule, it's an implied 1. Similarly, if there is not a subscript number like here underneath CO2, it's an implied 1, that there is 1 atom of carbon and 2 atoms of oxygen. So just to kind of understand a little bit more about where these numbers come from. Now, what I want us to kind of, aside from taking a look at that, let me just erase this real quick. I want us to take a look at, everything in nature is balanced, and with things being balanced, that means that the same number of atoms on this side of the equation, so the number of atoms there needs to equal the number of atoms over here. Now, the one thing that I do want to point out is that obviously they are not the same molecules anymore. When these things are bonded together, this is carbon dioxide, right? And this is water. This is glucose and this is oxygen. We do not have the same things on either side of the equation because of the fact that we have undergone a chemical change. But the number of atoms, so there's like a theory that matter cannot be created or destroyed. It just can be rearranged, which is what a chemical change is. So if we look over here, kind of just trying to think about this, so our atoms are large letters that we have. We have C, we have O's, and we have H's. Are there any other letters on this side? No. So this big number, once again, is going to tell us how many molecules of carbon dioxide there is. What you'll do to figure out how many C's there are on this side of the equation, remember this is an implied 1, you do 6 times 1. So 6 times 1 is 6. Now, how many oxygens are there? Let me move my H real quick, sorry. I'm going to move my H. How many oxygens are there? Well, you do 6 times this 2 here, which is 12. And then I go to my next molecule. So 6 times this 2. How many H's are there? There are 12. Now, there's another O here, though, part of water. Remember, it's an implied 1 since there's nothing there. So 6 times 1, so that's actually 12 plus 6. So we have, because we have oxygens bonded with carbon, with the carbon dioxide, and we have oxygens bonded with hydrogen in the water. So if I look at this, I have a total of 6 carbons. I have 18 oxygens and I have 12 hydrogens. So what that means, in order for this to be balanced, remember it doesn't equal each other because of the fact that there are 2 totally different sets of molecules on either side of our yield, which is our arrow. We need to make sure that there are the same numbers over here. So if we look for our large letters, we have C for carbon, H for hydrogen, and O for oxygen. So here's our first good step. Do we have any other atoms, CHs or Os, from the left side of the arrow to the right side of the arrow? No, right? So once again, that is at least a good step in the right direction. So remember, since there is no number here, it's an implied 1. So 1 times 6 is going to give me 6 carbons. 1 times 12 is going to give me 12 hydrogens. 1 times 6 is going to give me 6 oxygens. Now, don't forget about this one. We have 6 times 2 for the oxygens, so that's plus 12. So once again, I have 6 carbons, I have 12 hydrogens, and I have 18 oxygens. So if you look over here, oxygens are 18, oxygens are 18. Hydrogens are 12, hydrogens are 12. Carbons are 6, carbons are 6. There are the same number of atoms on both sides. They have just been chemically rearranged so that we have a new substance after our chemical change. Now, I'm going to work through something pretty similar with our cellular respiration equation here. And now just remember, in the photosynthesis, we have sunlight being the energy that's the driving factor here, right? So now let's take a look at what happens with when we do a, let's see, a different color there. I like that color. When we do cellular respiration down here. So once again, remember there is an implied 1 there, and make it a little thicker. There's an implied 1 there, and when we look at our different atoms that we have carbon, we have hydrogen, and we have oxygen on this side of the chemical reaction, which is our glucose and oxygen, right? This is my glucose, and this is my oxygen. And then I have my carbon dioxide that's made after the chemical change happens inside the mitochondria, plus the water. And then now remember, ATP is our usable energy, also known as adenosine triphosphate. So let's take a look at how many carbons we have on this side. So 6 times 1 is 6. 1 times 12 is 12. 1 times 6 is 6. 6 times 2 is 12. So once again, I have 6 carbons, 12 hydrogens, and 18 oxygens. And let's see what happens after the chemical change happens inside of the mitochondria, and the molecules now are rearranged and the atoms are now bonded with new things. So 6, and since there's not a number here, it's an understood 1. Let's get our different or atoms that we have here. 6 times 1 is 6 for carbon. 6 times 2 is 12 for oxygen. 6 times 2 for hydrogen is 12. Remember, there's an implied 1 there. 6 times 1 for oxygen is plus 6. And then ATP is its own type of energy source. So that's actually not a molecular structure we're going to take a look at. So if you see in this one, now once again, we have 18 oxygens, 18 oxygens, 12 hydrogens, 12 hydrogens, 6 carbons, and 6 carbons. So you can see that once again we have a balanced equation. We haven't lost any carbons, hydrogens, or oxygens. They have just been chemically rearranged to make new molecules. The other thing that you may have noticed is, if I were to just erase this super fast, sorry. Okay, let me get rid of this super fast. Hopefully, if you weren't in class, this is something that you may have missed. But the one thing that I do want to point out is that if you take a look at these equations for photosynthesis and cellular respiration, one thing I do hope that you notice is that the reactants, so remember, these are the reactants, right? And these are the products. So the reactants of photosynthesis, the carbon dioxide and the water, if you look to the products of cellular respiration, we have carbon dioxide and water. And then if you look to the products of photosynthesis, they are the reactants in cellular respiration. So the biggest thing that I want you to take away from this is that photosynthesis cannot occur without cellular respiration. And cellular respiration cannot occur without photosynthesis. So it's almost like a cycle where one has to happen in order for the other to happen, because then there would not be the reactants to either chemical process. I hope that this video was helpful, especially if you were confused about how the equations have even related to this and how the numbers were there and what they all meant, and how everything in nature likes to remain balanced. Feel free to go back and rewatch this if you are confused at any point in time.